What is up, folks? It is BatTube here, and today we are going to be looking at one of these Amazon spot welders that you can get for super cheap, around 20 US dollars or mid $30 Canadian, which is in my case. So these things allow you to easily replace something like that sun code that I featured in the other video. One of these pieces of crap that you can kind of see. It's a piece of shit, and I'm not even gonna pull that out. So the one of those goes for about like 150 Canadian, sometimes more, sometimes a little less. That's if you get it off of Amazon. You can get it a little bit cheaper directly from China with a bit of a wait. But with this so cheap, you would wonder why you would not go with an option like this, other than obviously the interface on the other one, which is not great in itself. It's really shitty, so it's not like you're gaining much with the interface. I do want to in the future do a project where we combine these two to use the interface of the Sunco and the actual welding from this board using a lipo. Okay, so let's get into this. You can get these kits. It comes with everything that you see here. So you get 2 power leads to connect to a LiPo battery or lead acid battery, whatever battery you choose to, a high amp output battery. We will get to that in a moment. But here are some your spot welding leads that you connect, as well as some screws and nuts to allow you to connect them to the board. You have some heat shrink to insulate these 2 leads. It also comes with some nickel strip. I don't believe it's pure nickel. I believe it's nickel plated steel strip. I don't know how thick. I believe maybe 1.5 or 0.1 of a millimeter. So it comes with a couple things, as well as obviously the board and 2 components that you need to install. It comes with a 25 volt, 2200 microfarad capacitor, and as well as a buzzer. The buzzer is for auditory signals, so you know when it's spot welding. So it does say to remove this, but I would suggest you leave it unless you want a really loud beeper. I prefer to leave it on just so I can hear the beep. I don't need to hear it loud, just need to hear it clear. Alright, so these 2 components go on the board. You have the buzzer, it goes in B1, there's a positive indicator on the bottom, and on the buzzer in the light there's a positive indicator right there. So you match those up, and it fits in quite nicely. Just enough so you have enough on the back where you can solder them in. So that is one of the components that you'll have to solder onto the board, as well as that capacitor that we were talking about earlier, the 25 volt, 2200. That goes in here with positive and negative. On capacitor, you will have negative right there, marked out like so. So you just have to put the negative and the negative and solder it. Now you can either have it sitting up like so, or my plan was to have it like so. Laying sideways was my intended position for it. So depending if you want the capacitor to stand up or lay on its side, both of those positions require different lengths of wire, so make that decision prior to soldering, because you can only make that decision once after you snip off the excess. Alright, so I fired up the soldering iron, got it heated up, and we're ready to solder on the first component. So all I'm going to do is on the back of the board, I'm going to take some flux, and on the 2 parts where we're going to be soldering to, this is very messy. I don't currently have liquid flux, I ran out, so we're using messy soldering paste, which makes a bit of a mess, but it works great all the same. So that's going to be plenty of flux. We're going to put the buzzer through, aligning it positive to positive. And because we have the gap, we can actually put the capacitor in just to hold it up when we set it upside down. Alright, so I've zoomed in so you guys can see this. It's very simple. Get some solder. Now I haven't trimmed the lead yet. I'm soldering first. Now I will wait for that to dry, just because before doing the capacitor, I want to make sure that it's aligned correctly. So if you can see, when we put it in, it can either go left or right. So we want it to stay fairly straight. So if we watch the leads as we're working, we can see which direction they're leaning, so we want them to be pointing straight up. So I will once again support it and move it over till the leads are straight up. And we'll do the same, being gentle not to bump it. I'm currently standing up and this is on the desk down there, so it's kind of an awkward reach, but we got it nonetheless. So give that a second. It's probably good though. It's on a bit of a lean, but it's no big deal. Alright, so we've got both components soldered and complete. They look on there just fine. So now the excess lines, we're going to take some side cutters and trim those flat. Alright, so now that we've got the components soldered on, we've got them snipped off, and we got the area cleaned below. You can either choose to fortify both the bottom and the top, or just the top and the spots that you're connecting. I'm actually going to be putting the ring terminals on the bottom, terminals on the bottom side of the board. So that is the main area where I'm going to be fortifying with solder. We're going to be adding solder to these 4 contact points, and that's going to allow more current to flow through these. These traces look fairly decent as it is, but it looks like there's a fairly thin layer of solder, so it could definitely benefit from more solder and potentially raise the amount of current this board can handle, and I will go into that now as we're soldering. I did some research on the MOSFETs. They're N-channel MOSFETs. They're good up to 40 volts, but you cannot use 40 volts on the system. I will explain why after, due to another component. The MOSFETs on this board are 40 volt MOSFETs, able to handle 300 amps of current. So the rated 150 amps for this board is slightly underrated, although there are other variables obviously at play, such as the size of the wire over there, and as well these traces on the board. They can only handle so much current. So that is one of the reasons why I am beefing them up. The IC is a regulated 5 volts from a voltage regulator. That voltage regulator is actually limited to 20 volts, as well as another diode on the board is also rated at 20 volts. So I wouldn't necessarily recommend putting anything more than 20 volts through this board due to that component factor. That is your component that is limiting voltage, so that is why I like working with 6 volts maximum, because any higher than that with LEGO, any other battery with LEGO will be putting you over that potential around 20 volt mark. Let's just bounce over this. It's not saying where I want it to, and my hands are really the best right now. The whole house will got COVID, so I'm not feeling the best right now. Okay, that's pretty good. I definitely see an increase in the trace size. I'm going to drag this one back to smooth it out. Okay, so the traces on the back are definitely improved from what they were. So now we're going to go around the front. As you can see, I'm not sure if you guys will get the same one as I did, because all the ones that I've seen on YouTube already, and the Google Photos, and even the Amazon link where I got this, did not have these brass bars installed, and I'm assuming that's for current handling, which is a good thing in our case. So if you have an uneven solder layer due to just improper movements or moving along, go around kind of in a loop, drag back and forth, and you will smooth it out. Alright, so here's how the board looks with all the solder on it that we have just put on it. Looks a lot better, a lot beefier than it did before. The little bridges we did up to the brass bars there look nice and look like they have good contact. The board has cooled down, so I will wipe it down with rubbing alcohol now. But the next step, if you were to leave this board like this, like most people will, is to decide what type of battery you want to use before you even put your connections on. Now, this is a big thing, and this is the reason why many people have had bad luck with these type of PCB spot welders. There's a couple of these versions, but for the most part they all use this same type of N-channel MOSFET. Some of them just have 5, some of them have 6. So that's basically the only difference between them, but they have somewhat a bad rep because mainly people improperly using them. Now, to decide battery, I wouldn't use anything other than a lithium polymer battery, and that is due to the brute amp output from a single battery, depending on the C rating, which is what we're going to talk about now, and how you're going to decide which type of battery you want to use. So here I have 3 batteries, all by Turnigy. Now, they all have different capacity ratings. For one, these 2 down here are 3S's, 11 volts. And this one is a 4S. Okay, so the C rating is basically the current handling capacity. Now right here on this battery it says 10C discharge. So you have a 10 amp hour, 10,000 milliamp hour battery, 10 amp hour, and you have 14.8 volts. Now luckily with the C rating, it's actually fairly easy. You don't even have to worry about the volts. All you need to know is the C rating and the capacity. Now, using the amp hour rating, not the milliamp hour rating, you can do 10 multiplied by the discharge rating, 10, and you will get 100. And that will be 100 amps of discharge. This one down here, you have a 5 amp hour at 40 C discharge. So that is going to be 40 times 5. So that will be 200 amps out of this battery. So this is able to handle 200 amps. This one's able to handle 100 amps. I believe I did that right. Oh, sorry, for 160 amps. I thought that said 50C. So at 40C discharge at 5 amp hour, that is 160 amps that this battery can output. Now this one's fairly crazy. The Turnigy Nanotech high discharge, you have 3.3. Now using a calculator, because I'm not that great at math, you can do 33 times 65 and get. Alright, so that would be 214 amps at 65C. It has the potential to output 130C. I'm assuming that's not constant, that's probably a burst. So at 130C, that's roughly 500 and something amps out of this battery. So this one's crazy. Now, I'm gonna not use something like this because at max, these MOSFETs can handle 300 amp. And there is no current limiting other than these MOSFETs, so it's going to put the full current load of this, or the full current potential, discharge potential, out of this battery. Alright, so now that I've explained that, hopefully most of you guys already knew that, but for any of the newbies that are just using the LiPo for the spot welder for other 18650s, that's how to do it, and I wouldn't use any other battery because it cannot pull amps out of nowhere. Like, it can only pull what the battery can potentially provide. In that case, we are going to put these aside and we are going to work on connecting these up. So we are going to be starting with this 3S 5.0 Turnigy. It is a little bit bloated, but it should be able to do the job just fine. It does have 8-gauge wire on it, which is a little bit overkill for this, but that's what came with the battery, so great. As you can see, the interface on it, can't remember what this is called, but I went ahead and found another one that I can use as the opposite, like so, that I can use to hook up to the board. Now this is 10 gauge, which is probably more appropriate for the amps that we're going to be pulling out of it, but actually it's kind of not appropriate. It's kind of, I'd like to have more, but what we're going to be doing is making the most out of this. As you can see, we got an in positive and an in negative. So we're going to have the connector basically right here. So I am going to be cutting it there and there. The shorter the wires, the less resistance and the more current capabilities it has. So I'm going to be shortening these wires up as much as possible before I put on the ring terminals. Now, I made the decision to not use ring terminals and actually solder it right to the board. Now, you can go ahead and use ring terminals and use the screws and nuts provided. That's all up to you. I am trying to minimize any resistance in any place I can, so I would rather a solid solder joint. So that is what I'm going to be doing, and I will be soldering it onto the bottom. So if you decide to go the soldering route, you don't have to do anything to these probes that they gave you. These are nice copper lugs, so what I'm going to be doing is, depending where they go, this isn't the right place, but for this one, this is the right place. I'm going to be soldering the copper lugs directly to that instead of cutting this back and stripping it, which is also an option. Okay, so I'm just now going to be soldering the negative probe to the out negative. If you are going the nut and bolt route, all you have to do is press this up to here and put the nut and bolt on. This is the only contact that connects to here, so it's as easy as that. Alright, so with a little help and struggle with the heat gun and the soldering iron, I did get this one on. I just didn't have enough magnets and helping hands in place to really do it properly, so I was struggling for an extra hand, and when I did, I'd put something down and then I'd lose the heat. So I eventually got it to the place where I wanted. I did not want to be heating up this board that much, but it doesn't matter. This whole board is put together with heat, so it's not that big of a deal. It just would have made more sense to put these two components on afterwards. But in that case, we're going to be moving on to the next one, which is going to be the negative and the positive battery lead on the back. The ring terminal is going to be soldered on the top. So this one we will be doing the same thing on the top using the solder. So we will first tin this ring terminal, and then using the soldering iron and the heat gun, we will press it down to here. So first, tin on this, tin top of it, and using soldering iron, we want it. It's going to be a bit of a cold solder, as the soldering gun sucks. That's why we have the heat gun. You guys may not need that way either. I don't know why the soldering gun's not working. Alright, so we're going to take the heat gun, see if that's working. Alright, so I did go ahead and solder these on using the heat gun and some solder. I'm pretty sure some of that went out of the seam because it kind of got pulled over here. But that's nice, and that's done. You can go ahead, you don't have to use this connector. Obviously, you guys probably went ahead and used your own connector, or you probably went ahead and used the bolt-on method like I didn't do. It's probably saved you some time, but this is how I ensure it's going to get the best contact. Alright, so at this point, you've either soldered on a battery connector, you've bolted on a battery connector, you've bolted on your battery, or something to that effect. We're about at that point, we're ready to do some spot welding. Now, I'm going to use the heat shrink that they supplied and just quickly insulate these. Okay folks, so here we are. I've got the board all finished up. I did a couple things off camera, such as finally switching off that small puny solder tip to a larger one so I could actually put these ring terminals on properly. As you seen, I was struggling earlier. I also changed the position of the battery connector to face out the back instead of outside. Next step is to hook up your battery. In this video, I'm only going to be showing you guys how to use a 3S battery, because in my tests I did off camera, that is all you need. You can use a 4S 14.6 or 14.8 volt battery if you would like, but just user beware. There is the potential to blow through the back of the cells and have electrolyte spill out, even on low settings. So I did a test with a 14.6 volt battery, and on the second setting on the spot welder, it blew a hole in the battery. When I had the leads not pressing hard, they were very loose, so it created an arc in between the probe and the nickel strip, which actually put a hole in the nickel strip and through the battery. So I'm only going to be showing you guys a 3S, because in my opinion that's all that's necessary, assuming you have a 3S that can output at least 150 amps. I would go for a 200 amp one to account for the resistance in the lines and any higher amp draw that the board may pull from it. Okay, so you guys may have noticed earlier that these leads were backwards, so I went ahead and flipped them on the battery to match these leads that I installed on the board. So we can just hook it up like so, and that is beautiful. all we have to do now, we'll lay the battery down, put it back there, hold the power buttons, turn it on. So depending which model you got, some of them will have 5 modes and the 5th mode will display a red light, and some of them have 5 modes and the 5th mode will display another green light. So when you first turn it on, it's in the 1st mode. So if you hold it, you'll hear 2 beeps, that's the 2nd mode. 3 beeps for the 3rd time, that's the 3rd mode obviously. 4 for 4, and 5 for 5. And you hold it once more, and it will shut off. Once again, hold it 2 seconds, mode 1, mode 2, mode 3, mode 4, and mode 5. And you're ready to go. It's all automatic, you don't have to press anything. So you press the probes to the battery, and once you press the last one, a little time delay, and it will fuse the batteries. So we're going to start it. I will show you guys 2 examples, one on the lowest setting and one on the highest setting, just to compare the brute difference between the 2. So with a piece of the nickel strip that they provided, we are going to put 4 on each cell, and then I'm going to use a 3rd one and see how it works pushing through 2 layers. But that's depending on how well this first mode works. So what I would suggest is use one of the probes and press. Now you don't want to press too hard because when you press too hard you actually create an easy pathway for those 150 amps to travel, and it won't create enough of a resistance point to create a spot weld. You actually want right in the middle. You don't want a loose connection where it's kind of hanging in the air, kind of tapping, and you don't want a very tight connection because either of those will end up in a bad spot weld. So I'm going to use the one probe to hold it there while I align it, get it exactly where I want it. Now that it's ready, I can bring the 2nd probe over, and just like that you'll hear a beep, and that means it's done. So once again I'll move over and do a 2nd one. I'll go over to this cell, once again align it using the 1st probe and push on the 2nd one. Okay, so this was mode 1, level 1, lowest level obviously, so I will just pull apart like so. And on this, 2 of the, oh, what the hell was that? Okay, so 2 of the 4 contacts punctured right through the nickel strip, and on this one, all 4 punctured through the nickel strip, but it wasn't a solid weld. There is no residual nickel strip on the batteries, so that's indicating a bad weld, but that's kind of to be expected from the lowest setting. So what we will do now is just for shits and giggles, we pretty much know how this is going to go down, but we are going to see how well level 1 can go through 2 strips. Well, we got the 2 strips together, but not to the battery. And once again, yeah, it's not possible. So it did weld those 2 strips together nicely, but it cannot get those through those 2 strips to the battery. Alright, so in complete contrast, we're going to go to mode 5. So we're now in mode 5, which is the highest mode on the spot welder. We are using the 3S battery capable of outputting 200 amps. It's charged at 13.8 volts. Just so you guys know for a reference. Once again, same thing. Okay, so you may have noticed it was just you won't be able to notice that much, but it was much stronger of a weld. And if I go like this, yeah, it ripped right through, and in both cases there was nickel strip on the battery. So yeah, that ripped the nickel strip right out. That was pretty good, but not that great. Let me just check the voltage of the battery. Alright, so I'm just gonna quickly show you guys an example of the different ways of contacting when you're using the spot welder, and how you can get really bad spot welds from this same setting. So I want to show you guys an example. If I take one of the probes, and this is actually harder than you think, and press it directly flat down, and then I take the other one and I come next to it and I press directly flat. Now when I pull off, if you notice, because like I mentioned earlier, there's barely anything, and I can actually just make it fall off. And that's on the 5th level. That's on the highest level that the spot welder can produce. And that is because obviously the flat part of this is going to provide a lot more surface area than if we just use the very edge. And that is exactly why we're creating a nice path for that 150 amps to travel, when that is what we're using to weld. We are actually using the resistance point to weld, so we want to create a big resistance point. To do that is you can then take it and put the probe on its edge like so. Now if you see, there was a lot of sparks there, and we're going to go right to the edge just like so. And that was amazing. It ripped right through, leaving pieces on there just like so. And that was on the same level that I just did that last spot weld. So let me show you guys once more. We'll do another flat one and see how bad of a weld it produces. So once again, flat. It's actually kind of hard to do this. And flat, well, may as well make it fairer and do 2. Now I'm just gonna twist it. Oh, this one kind of held, but barely. Okay, so once again, with the sharp edge, we're gonna get it to stick real well. Okay, so test on the edge. And just for shits and giggles, over here, I'm going to show you what happens when you lightly press. Once more. As you can see, there was a lot of sparks because the probes actually just melted a hole right through the nickel strip and didn't even weld anything to it due to that. It just melted a hole through it. And that is how you can take the 14.6 volts and actually puncture the cell, is in the same way. Anyways guys, this spot welder can definitely take out that sun coat completely, and you can definitely get away with welding some batteries with just one 3S battery capable of outputting 200 amps. You can also put 2 of these in parallel, and you would actually gain a bit more of a current output. But other than that, I would suggest sticking to the 3S. But if you want, you can go ahead and use some 4S's like I have over here. Just use at your own risk. Anyways guys, thanks for watching. If you guys enjoyed, please leave a like and subscribe. I appreciate it. Have a good one.